Welcome back to Trig Notes 1.4. This is part 2, or Pre-Calc 4.4 Notes part 2. If we continue with the concept of reference angles here, if I'm asking you to find the reference angle of this problem, notice it's a negative radians, so this would be 0 pi. And if I work in negative radians, it'd be negative 0.5 pi, negative 1 pi, negative 1.5 pi, and then also negative 2 pi. So I want to start here and draw my angle till I get all the way around to negative 1.7, which would be right around there. But again, what I want to know, if this is negative 1.7 pi, I want to know the reference angle, which is from the x-axis in the first quadrant, going over to the angle. I want to know what this angle is here. So if I kept going, I'd get all the way to 2 pi, but I've only went to 1.7, so I really want to know from 2 pi what is the difference if I subtract 1.7 from there. So that would be 0.3 pi. I'm not concerned about the negative here because remember, reference angles are positive. They're not negative. So this measure here is a positive 0.3 pi. Next thing I want you to do is to get out your calculator and plug in the sine of 160 and the sine of 20. Now when you do this, make sure your calculator is in degree mode. When you do it, you should notice that you're going to get a decimal, 0.3420, and for this one you get the same thing. Now the whole reason we've been working with reference angles is that they have the same sign. These two are reference angles because if I draw 160 degrees, start here, 160 would be around, or right around there. That's 160 degrees. The reference angle of 160 degrees, this angle, to get all the way to 180, I'd have to go 20 degrees more, would be 20. So these are reference angles to each other, so we can actually use the sine of 20 to help us figure out when we're dealing with the sine of 160. They're exactly the same. And that's the whole reason that we use reference angles here, is that they're the exact same thing as what the larger angle, the non-reference angle, the 160 degrees, would be. So if I'm thinking about how do I actually use this information of this concept of the reference angle, here's a problem where we would actually use a reference angle. We would look at this and say, okay, the tangent is negative and the cosine is positive. So we want, where is the tangent negative, negative 4/3 here, and the cosine is positive, greater than 0. So I'm thinking about which quadrants that happens in, and I know that the cosine is positive in quadrants 1 or 4, so in these two quadrants. Tangent is negative in quadrants 2 and 4, and so this would have to occur in quadrant 4. So if it's true in quadrant 4, let's make a reference triangle in quadrant 4. So again, we go from the x-axis in this quadrant, make an angle coming from the origin, and then we draw our triangle. So it would look like that. So that's the first thing we're going to do, is identify the quadrant, and we said it was quadrant 4. The second thing that we want to do now is we want to make a triangle that has a tangent of 4/3 where it's actually negative. Now don't let this negative up here fool you and assume that the 4 has to be the negative. We'll figure that out once we put it onto our triangle by using the idea that tangent is the opposite over the adjacent. So from this angle, our reference angle, the opposite side is 4, the adjacent side is 3, and when we think about this, this would have to be negative 4 because our y values are negative here, where our x values are positive. So it just so happens that the 4 was the negative, but really I'm writing this whole fraction as negative 4/3, but I don't necessarily know if the 4 is the negative or the 3 is the negative. It just so happens that the 4 would be negative based upon the triangle here. Now that I have the correct triangle, I can actually do what the question asks, which is to find the sine and the secant. So step 3 would be to find the sine of our triangle. So I know that sine is equal to opposite over hypotenuse. Opposite is negative 4. Hypotenuse is, I don't know. I gotta find that. So really, the fourth thing that I need to do, which is going to help me find the third thing that I needed to do, is use Pythagorean theorem to solve this triangle. So we would say 3 squared plus negative 4 squared equals c squared. 9 plus 16 makes 25. So I know then that this side of the triangle has to be 5. Which will help me now that I can say this, that my hypotenuse is 5. One thing also that you should always pay attention to is your hypotenuse will never be negative. So you're never going to get a negative number here for your hypotenuse. Your sides of your triangles could be negative, like this one is in this problem here, negative 4, but your hypotenuse will never be negative. So that's our sine. Finding the secant then would be the fifth thing that we're going to do. Secant of theta, I wrote sine, secant of theta. Secant is the opposite of the cosine, so the cosine is adjacent over hypotenuse, so this would have to be hypotenuse over adjacent, 5 over 3. And so those would be my two answers then. So thinking about this again, if the cotangent is negative 3 and the cosine is less than 0, I want to find the sine and the secant. So again, I need to figure out where to draw my triangle. So first thing I'm going to do is figure out the quadrant. Cotangent has to be negative, and cosine has to be less than 0, so that means negative also. So I know that cotangent is negative in quadrants 2 and 4. And cosine is negative where the x values are negative, which would be in quadrants 2 and 3. So what I've found then is that my triangle has to occur in quadrant 2. So draw a reference triangle in quadrant 2. So go off the x-axis here. Then make your angle come out from the origin, and then make the right angle there. So this is the triangle that we're going to be dealing with. Now what we want to do is draw that triangle so that it has a cotangent equal to a negative 3 over 1. Again, I'm not sure which one of these is negative, if it's the 3 or the 1, but I do know that cotangent is the opposite of tangent, so this would have to be adjacent side over opposite. So adjacent side would be 3, opposite side would be 1, and looking at this triangle, this is the x value has to be negative, so the 3 is negative and the 1 is the positive. Again, it says here negative 3, but it could have very well easily been a negative 1 if maybe this was in a different quadrant. So don't just assume that the 3 is the negative. It happens to be here for this one and for the previous one, but it may not always be that way. Okay, so we found our correct quadrant. Let's go through and next step, let's make our triangle here for the sine. If I want to know what the sine is, that's opposite over hypotenuse, so I got to find the hypotenuse using Pythagorean theorem. 1 squared plus negative 3 squared equals c squared. 1 plus 9 would be 10. So I'm going to get c actually to be the square root of 10. Again, the hypotenuse will never be negative. So this would end up being sine would be opposite is 1, hypotenuse would be square root of 10. Always rationalize whenever you can. So here I'd get rid of the square root of 10 on the bottom by timesing by it. So I'd end up with my final answer being square root of 10 over 10 for the sine. And finally, let's find the secant. Do that up here. Now I know the secant is equal to the hypotenuse over the adjacent side. So the hypotenuse in this problem was the square root of 10. The adjacent side is negative 3. I can't reduce that at all, so that would be my answer. Alright, this next one says if the sine is 1/3 and theta is in quadrant 2, find the cosine and the tangent using identities. So, if I think about this, quadrant 2 would be a reference triangle that would look like this. Remember, it's got to come off the x-axis. Sine is opposite over hypotenuse. So 1 would be opposite. Hypotenuse would be 3. So I've got my triangle here. Now I can actually find the cosine Now remember, the cosine is equal to the adjacent side over the hypotenuse. I don't have the adjacent side. So let's go through and do Pythagorean theorem. This time I'm given the hypotenuse, so 1 squared plus, we'll call this side b, should equal 3 squared. Subtract the 1, and we'd end up with b squared being equal to 8. But I want to take the square root of that, so b would actually be, if I look at the perfect square of this, it would be square root of 4 times square root of 2, and that's 2. So 2 squared is 2. Now be careful when you do this, because I'll put this in here as 2 squared is 2, because algebraically I got it to be positive. But what I know is that the x values in the second quadrant here, the x values have to be negative. So this has to be negative because it's negative in the second quadrant. The x values are negative. So even though algebraically I get a positive 2 squared to 2, I want to make sure that I put it over here as negative 2 squared to 2. Otherwise, when I go through and find my cosine and my tangent, I'm not going to get the right answers. And that's where I notice a lot of mistakes being made, is that you plug it in here with whatever number you get instead of thinking about, should any of these numbers be negative. So now if I plug that in, negative 2 squared to 2 over the hypotenuse 3, that would be my cosine. Thinking about finding the tangent now, tangent is opposite over adjacent. Opposite would be 1, adjacent would be negative 2 squared to 2. So let's rationalize this by getting rid of that square root of 2. So square root of 2 in the numerator. This would be a negative 2 here. And then when I multiply these two square roots together, these two square roots, when I multiply them together, just become a 2. So what I really get in my denominator then is a negative 4. So I'd get negative 2, or I'd get the square root of 2 over negative 4 as the answer for the tangent.